Hi folks, it's Sonic again. I'm here with screencast number 4. I promised that this would be a quick one. It's entitled Osmosis, so let's get right to it. We applied this term, diffusion, right here, to what we were doing with our egg. So let's first just recap what has happened with our egg. We took a regular chicken egg, placed it in vinegar. Remember that vinegar is 95% water, 5% acetic acid. The acetic acid within the vinegar chemically reacted with the eggshell, which is made of calcium chloride, and essentially dissolved the eggshell. The eggshell was repurposed into other materials. It's not there anymore. And it left behind the membrane underneath, the insides of the egg, but an egg that was noticeably larger, both mass and in overall size when we measured it quantitatively. So the question becomes, why did that happen? We then took this egg on the right here and we placed it in water with food coloring. Most people found that the egg expanded even further, especially since it was in that water for 4 straight nights. But it also was the color of the food coloring. Most of you used red. So not only was it a larger egg, much larger, a more massive egg, but it was a different color, which implied that the water continued to go inside the egg. So the question is, why did that happen? So let's again look at this definition of diffusion. Diffusion is a very general term. It is the movement of a fluid from an area of higher concentration to an area of lower concentration. We also refer to this as a passive movement. When I say passive, I literally mean without the use of any type of energy. It just naturally occurs. So the definition, the second definition I gave you was osmosis. The definition of osmosis is diffusion of water molecules across a semi-permeable membrane, again, without any energy. But it deals with water and it deals with the semi-permeable membrane. Our cells all have semi-permeable membranes. Water is critical for a cell's survival, for all of the different functions, all the different processes, for life itself. Chemical reactions require water. So the water needs to come into and out of the cell, but it doesn't want to let the guts of the cell come out. So it's got to be semi-permeable. It's got to allow some things to come into and out of and not other things, namely water. So where does osmosis fit into our experiment? Tonight, many of you, most of you, have placed your egg in corn syrup. Corn syrup is this nasty, disgusting, thick fluid, thicker than molasses, thicker than what's the word I'm looking for? Thicker than syrup that you put on pancakes. This stuff is just thick, and I would argue a very, very low amount of water in it, a very low concentration of water. So let me show you this diagram here. Where's my diagram? I lost my diagram. There's my diagram. So these little blue dots represent water molecules. The big red or orange circles represent another, what we call solute, another substance that's dissolved in the water or present where water might be. And here is our semi-permeable membrane. So you took your egg and placed it in water. So the egg is over here. It was placed in an environment surrounded by water. The water has a high concentration on the left-hand side, a lower concentration on the right-hand side. The water seeks balance so that you have the same concentration of water on both sides. So what naturally occurred with your egg, both on day 1 and day 2, quite frankly, is water from its environment moved inside the egg. And quite frankly, it probably went back and forth a bit until it found its balance. The net result was an egg that absorbed more water because there was more water outside than inside. But now you've placed this egg. Where's my egg now? Ah, where's my egg? Here's my egg. Now this egg has been placed in corn syrup. So if we go back to our diagram, now you have an egg with a lot of water in it, surrounded by an environment that does not have a lot of water. What do you think will happen? We'll find out tomorrow. Have a good night.